Hey guys, Chaz, Black Horse Motorworks. Today's video is going to be something interesting. So we often see these McLaren water pumps fail, and we aren't entirely sure why. I'm pretty sure it is the seal that separates the oil chamber you see here, where the timing chain, or I shouldn't say timing chain, the drive chain drives the water pump assembly and the coolant passage. There's a seal that separates those two. Pretty sure that's the reason for failure. There's a weep hole right here on the bottom, and that is where the coolant often seeps out. Anyway, so what I want to do is take one of these old pumps that we have, and I'm going to tear it down on the bench to give you an idea of what's going on. Alright, so here we have the water pump assembly. This is the coolant chamber here. This is the input. This is where it pulls the coolant out of the engine, and this is where it pumps it out towards the radiators to complete the cycle through the rest of the system. This is your heater core hoses right here, and then this is the drive chain attachment right here. So this is the front of the engine typically, and this faces backwards. This is the gear that intercepts the coupler with the AC unit. So the chain drives the system from this end. The shaft runs all the way through, drives the water pump. Shaft outputs to this, goes to a rubber coupler, and drives the AC unit. So I'm going to go ahead and start the teardown and just kind of walk you through what I see here. First thing I'm going to do, this bolt is reverse thread. Out of the way, pull the pulley off. Okay, next up, snap ring, a little wave washer. So over here, let's see, wave washer, snap ring, bolt washer here. Alright, drive pulley. Now I'm going to take the case bolts out. Just one, if you notice, one bolt that's black right here in this corner. Others are all chrome. Just something to take note of. Okay, this is primarily your heater core chamber, so this is drives that pump assembly alone. So I'm supporting just the top cover right here, and then driving the pump shaft out. There we go. Set this to the side for a moment. So here's our top cover. So we've got one seal back here, and then we have the main pulley, or I should say bearing up front. I'll actually go ahead and yank that out as well. I think, yeah, I can actually just drive that out since I've already taken this C-clip out. Won't take very much force, but for safety reasons I'm going to use a brass punch. This one fits the center of the bearing pretty good. It should just pop right out. I'm going to use my plastic hammer because I don't believe it's going to take much force. There it goes. Bearing is out. Place that here. For now, I'm going to leave this seal assembly in. It looks like it could be a Teflon or a ceramic seal even. Not sure. I'll have to look into it, but you can see the design here. See this little weep hole on the inside, right down here at the bottom. So if this seal begins to leak, the coolant will run down into the weep hole on the inside you see here, which will collect inside of this chamber, and you'll actually see it start to leak around this plug if that occurs. And there's even a little teeny bit of coolant right here, but I don't believe that was leaking in this case, not on this piece. Alright, and more interesting, you can see this chamber is sealed with this O-ring right here around the outside edge. Alright, we're going to set this over to the side. Let's go back to our main housing. Alright, so let's see what we got here. We have, looks like I need to draw this sleeve off of here. Now this is going to be a tricky one. For the moment, I'm going to flip it over and go to the other side. Alright, so on this side we have a 4mm Allen. I'm going to grab a socket for that. This one is unfortunately a very shallow fastener, and my Allen is not able to grab it so great. So I'm going to go ahead and extract that bolt. For that, I should be able to get away with just using one of these quick extractors. Yeah, it looks like it should work pretty good. So, go in reverse with the drill bit side first, and I'm going to drill out the end of this bolt. There we go. Let's hope this one's not reverse thread as well. Okay, so it's a good sign, it's grabbing there. Got it, no problem. One of the most useful little tools in this industry. I'm going to leave it in the extractor for the moment so you can see it here, but yeah, oh, sorry, get it to focus here. Pretty nice. You can see there's some type of thread sealant or Loctite on the bolt. Alright, let's go back to this end. There's a washer here now. Let's grab a magnet. That's off, goes to that bolt. Alright, let's get this to lift up. It feels like it's a pretty tight fit. You see here, this is now lifted up quite a bit. I should be able to start getting it off all the way. It's really not that tight, it's just a very nice, oh there it goes, nice machined fit. Now for reference reasons, I'm going to take my washer and my old bolt and just set it like that so I can remember how it is there. Now these are equal splines all the way around, so there's no timing or alignment issues there. Alright, now I found another snap ring right in here. Let's pop that out. That one's out. Just like the other side, there is a spring washer. Pretty sure it just adds a little bit of preload to the system here. There it goes. That's how you can tell the same engineer designed both sides of this pump. Alright, I'm going to see, it looks like this could be driven all the way out the other side. So I'm going to give that a few whacks and see what happens. There's this mini sledge and a brass punch, not to damage the end of the shaft. Something interesting I'm noticing as the shaft is moving down, I'm noticing this bearing wants to fall out. So I'm going to go ahead and just take almost, can't quite get it out yet. Yeah, hi Vince.
Hi.
Doing a quick teardown of the water pump failure on a McLaren.
Why? Why?
To see what's going on with them.
They're garbage.
Something interesting, exactly. And it's out. Alright, move back to our work area here. So, that impeller is pushed out. You can see your housing. There is another seal down in here, right at the bottom. There's also a bearing. Oh, I think I can get it out. Just like that. That's the other bearing. Now if you notice something here, this bearing versus the one we pulled out earlier has no dust gasket in it. Now the reason is this bearing is on the coolant side of the housing. Coolant's not a lubricant, so you want to have this as a sealed, greased bearing. This is identical bearing, but it does not have the dust seal in it. Oh, there's a bushing. Oh, that's actually the center race. That's interesting. This is oiled by the oil in the timing housing, so it's exposed to that oil, keeps it lubricated. So there's a good chance that this bearing could last longer than this one, although they're the same bearing, because it's got a constant lubrication. However, this one's also influenced by any impurities that are in the oil. So I guess it depends on how the person takes care of their car. But, yep, a little something interesting there. Alright, so now all we have left is the seal in here in the housing, and then the impeller assembly here. Now I'm not going to tear this apart, but you can see there's a little gasket that separates these two. So it's the heater core side. You see it's got a smaller impeller, and then the engine coolant side. This is actually where it pumps coolant for the engine. There's an O-ring right around this as well. It's kind of hard to see. There's this. Looks like this actually may be crimped on, so this may not be serviceable on its own. And there is a seal right here around the face of it. And this is like a graphite style seal, the top. Alright, so now I want to take and try to punch out the failed seal here. Get my really big brass punch. This should fit. Yep, fits through the oil seal. And then I'm going to try to do firm strikes on this, knock it out. Ooh, pinched myself. And there, my friends. So funny enough, any of you Ferrari guys may recognize this. The old rebuild, the Testarossa or 308 pumps, this is actually the same ceramic style seal that they use in those. And this is in a brand new McLaren. Funny, that technology hasn't gotten any better. Or at least McLaren's not using anything any better. I'm going to knock that oil seal out I was struggling with. Now, you might ask, like, am I tearing this down because I'm just curious? And I would say yes, that's the case. I am just curious to what fails in these and what design they use. And however, at some point in time, just like any other cars, they will stop making these water pumps. And when they do, we have to fix them. So it's kind of nice to know what it's made of. You know, what's on the inside of it. Because technically, we're in a world now where you replace a water pump when it leaks. The old ways, and the ways we'll end up back at some point in time, is repairing the water pump. Because the actual failure is this seal. It's not the entire assembly, it's just this seal. But they don't sell just this seal. They don't make enough money that way. Plus they don't trust the technicians, including their own technicians, to install that seal. And I will say, this is a very delicate seal to install. You usually need a special press or a special socket. So when it comes time to replacing these, we will likely mill an adapter so that we can put this housing into a press and press the seal in nice and easy all at once. Because if you tried getting an adapter and hammering it in, it will likely crack this ceramic. And that will cause it to leak. Then you're having the same problem. Anyway, well, I can't get that oil seal out right now. It'd take a little bit more work to do it. But that is the internal assembly of a McLaren water pump. So, thought you might find that interesting. That's my first time tearing one down to the point of failure internally like this. Now we'll look into sourcing this part, which, big surprise, has no type of part number or any information on it whatsoever. So that'll make that a little bit trickier. But for future information, we know how it works.